Democritus, a Greek philosopher, was the first to propose that matter is comprised of fundamental and divisible particles which he called atoms. Though this marks the first time matter was viewed in this way, it was more a philosophy than the real science, and no supporting evidence was gathered for a long time until
John Dalton came along and provided the first empirical evidence that atoms exist. He proposed that compound consists of different types of atoms in whole number ratios, and the chemical reactions involve the rearrangement of those atoms to give new combinations. However, we soon discovered that Dalton's atoms were not the fundamental and divisible unit of matter that Democritus envisioned.
J.J. Thomson showed that an atom must consist of smaller particles when he discovered the electron. In this cathode ray experiment, particles ejected from a neutral material were shown to have a negative electrical charge. Since they were attracted to a positively charged metal plate, this means atoms must have within them positively charged and negatively charged particles. But he did not know how they were distributed, so he proposed this palm pudding model. Just a bit later,
Ernest Rutherford took it further with his gold foil experiment. He fired positively charged alpha particles, which are very tiny, at the thin foil of gold. He was shocked to find almost all of them passed right through to the detector on the other side, but around 1 in 8,000 scattered wildly and with high energy in random directions. This suggested that the positively charged in the atom are highly condensed in the center of the atom, which was given the name nucleus, and that the negatively charged electrons were far away, making the atom 99.95% empty space. That's why alpha particles typically pass right through, but if they are just perfectly aligned to strike a nucleus, the huge repulsion between the positive charges makes them fly violently in a random direction. So we arrive at a model that looks like this, which should be a familiar image.
Nailborn suggested the idea of the energy levels. He proposed his quantized shell model of the atom to explain how electrons can have stable orbits around the nucleus. He modified the Rutherford model by acquiring that the electrons move in orbits of fixed size and energy. The energy of the electrons depends on the size of the orbit and is lower for smaller orbits.
The current model of the atom was proposed by Erwin Schrodinger, an Austrian physicist. In 1926, he took the Bohr atom model one step further. Schrodinger used mathematical equations to describe the likelihood of finding an electron in a certain position. This atomic model is known as the quantum mechanical model of the atom. Unlike the Bohr model, the quantum mechanical model does not define the exact path of an electron, but rather predicts the odds of the location of the electron. This model can be portrayed as a nucleus surrounded by an electron cloud. Where the cloud is most dense, the probability of finding the electron is greatest, and conversely, the electron is less likely to be in a less dense area of the cloud. Thus, this model introduced the concept of sub-energy levels.